Is it better?
Yes, perfect. Yeah.
Thanks.
Okay.
Okay. So thank you for a great introduction, and I hope that some of the points that I will make in my presentation can, let's say, at least tackle some of the issues that were raised during the keynote. My presentation will be about sharing new type of threat intelligence, and I will give some use cases to explain where we envision that such an intelligence can be used, and then also briefly introduce the threat intelligence itself. And in the end, I'll mention some standardization effort regarding our threat intelligence, in particular cybersecurity playbooks. So what was our motivation? We set up several, let's say, research topics that we want to address within the SAPPAN project. Namely, it's to improve the detection capabilities, to improve privacy when sharing threat information, and to improve also reaction on some attacks and incidents. And basically researching these various topics, we had various ideas how to address them, and some of the concepts we came across, we used to and applied them in a new way in a threat intelligence sharing domain. So within this threat intelligence sharing domain, our goal was to extend the threat intelligence with new type of information while preserving the privacy, if possible, and at the same time to enable sharing, to support the sharing of such a threat intelligence. And by defining these goals, we wanted to address the increasing, let's say, set of tools that are being used by attackers, the evolution of malware, also the rising complexity of detection and how the attackers try to avoid the detection, as well as the automation of attacks. So let's go straight. So what type of new intelligence are we talking about? We let's say introduced or focused on two data, let's say, types. And the first is the machine learning classification models, and the second is playbooks. So let's first focus on the machine learning classification models. We consider that the machine learning classification models, the classifiers, they can be the new indicators of compromise. And why we think that? Because they can capture more information. They have better expressive power than, for example, an IOC that we are using today. For example, if we use a file hash, we have a hash of a particle file. But when we use a classifier, then we can probably classify the whole family of the similar files. And we can continue to other type of problem, not only files, but we can classify behavior. We can classify what we have seen. We can classify a list of domain names. So we think that the machine learning classification models will become or can become at least a new indicators of compromise. How it can work? We studied two types of use cases. One is the, let's say, the indicator of compromise, and that is there's one organization that has the machine learning capability, which means that the organization has data, usually annotated data, which enables the organization to train a classifier. And then the classifier is shared with other organizations that do not have the data. They receive the classifier and they can use it to analyze, for example, the data from their infrastructure. This is a, let's say, IOC example. To be, let's say, specific, let's consider distributed denial of service attacks, and let's consider some organization that is under such an attack, and such an organization can describe the attack by a DDoS fingerprint, and the DDoS fingerprint can exactly be a machine learning model. In particular, at SAPPAN, we investigated how to use decision tree to represent such an attack. And actually, the decision tree can be represented as a set of and/or rules. So that's simple. But if we consider some more advanced machine learning models, such as random forests or neural networks, then we cannot no longer represent it as the rules, and we have just the model. And we can use it actually to inform other organizations that there is such an attack. And if then we took the second component that we are also presenting in this presentation, the playbook component, then we can connect. If you see such an attack, then you can use such a playbook. That's the first use case of using the machine learning model and sharing them. The second use case that we've been investigating at SAPPAN is how to improve the detection capabilities. And in here, we have specific example where multiple organizations are able to train their classifier. So they have the data, they have the capability, but they all want to have a better classifier. So they would ideally like to collaborate in the training the classifier, but they fear sharing of the data, of the raw data. Therefore, we investigated various approaches, and in this particular example, we use federated learning approach, where only the improvements to the model in a single epoch of training is shared with the others. And by sharing the local improvements of an organization with other organizations, the organization arrive at better classifiers, at training better classifiers. So this is the second example of using machine learning and sharing the machine learning classifiers. Of course, maybe in future we can come up with more, but this is what we investigated at SAPPAN. What we did is we integrated sharing of the classifiers in a MISP. So we selected a MISP thread sharing platform as our primary, let's say, prototyping platform, because it's quite popular, used, and supported. And we prepared a MISP object to represent the classifier. And the classifier, the MISP object is not specific to a particular machine learning method. It can carry classifier, be it either random forest, be it neural network, doesn't matter. So it can serve also multiple use cases. It can serve both the use cases. It can be IOC, or in a different case, it can serve to it can serve organizations to participate in collaborative machine learning. And actually, it's quite simple. It's just an object where there are metadata which describe the model format. So, for example, if it's HD5 or other type of representation, then the use case, so what type of problem is being used, the description, of course, you need to describe when you are, for example, using the classifier, you need to know what are the inputs and what are the outputs. Then the unique ID might be useful during the collaborative learning to represent the epochs. And then the classification model itself. This was a little bit simplified, but it's like that. And yeah, we prepared the prototype and tested it. And we were successful in training a better classifier, which I believe then a colleague of mine will talk a little bit later on in the next presentation. Therefore, I will focus on the second bit of the presentation, and that are the playbooks. So why do we need playbooks? Basically, the motivation is to describe, the playbooks basically describe the response and recovery steps, but maybe they can also be used to not only response and recovery, but also to during the preparation cycle. So they can describe even the steps, how to prepare for an attack to come. When we want to share the playbooks, we want also the other party to understand the playbook. And ideally, we do not want only a human to be able to read the playbook, but we want a machine to read the playbook and ideally also to understand the playbook and then interpret it. The playbooks are also sometimes called workflows if the playbooks are not high level, but are already at the machine level. They are either semi or fully automated, which means that some require a human to intervene during executing the playbook. Some do not require it at all. And about the playbooks, it's nice that the playbooks brings a repeatability in the process. It's basically a guideline of steps, what to execute, which is very nice to document the process, to monitor the process, and to improve it. And by sharing, we can, sharing such information, we can improve it either collaboratively or in another model. There might be playbooks shared based on some commercial agreements. So similar like in sharing ideas rules, there might be an open version as well as a commercial version. So at SAPPAN, we worked on how to capture the response and recovery steps into some workflows. And we come up with a SAPPAN format, but in parallel also there was an OASIS activity which introduced CACAO standard. So in the end, we decided to go with CACAO and let's say consider this as let's say future for the playbook sharing. And therefore we took the CACAO specification and decided to integrate again the CACAO representation of playbook into MISP. So but again, we didn't want to prevent also other formats of Playbook to be shared. Therefore, the specification is general, and the MISP object can host also other formats. And the MISP object consists of metadata, again describing the Playbook itself, such as the Playbook standard. So if it's CACAO or if it's SAPPAN, or if it's other type of Playbook, for example, described as BPMN, Playbook type. So if it's described in JSON, XML, description, what it's about, what person roles are involved in the Playbook, if any, what's the level of abstraction, if it's a high level at the level of guidelines, or if it's already executable workflow, how long, if there's, let's say, limited validity of the Playbook. So if the lifetime of the Playbook should be somehow restricted, and then the Playbook itself. So this, let's say, general description then allows to accommodate any Playbook and does not require to introduce new object with a new Playbook standard. And how it may work in, let's say, the context of an organization. We envision that an organization has a database of Playbooks, and this database of Playbooks is, some of the Playbooks are shared if they are useful. For example, if we report some incident as a search team, I'm, let's say, a little bit affiliated with a CERT team of CESNET, and CESNET connects multiple organizations and reports them incidents. We want the organization to know what they should do when they see an incident, when they receive the report. So that's how we can express what are the next steps, what they should do. So we report the incident, and ideally we would like to attach the Playbook so they can act upon based on the Playbook. And ideally at SAPPAN we also went a little bit further, and we tried to, if it's a high level Playbook, we tried to translate the Playbook into a workflow that is more machine executable, and then this workflow can be executed by a response automation, which later on in the during our event will be presented also by my colleagues. So let's say just a few slides about the standardization to explain what we did. So at SAPPAN there was a whole task to capture the response and recovery steps and to standardize them. We introduced the standard in the deliverable at the same time where the first standard of the CACAO was also introduced, and that's how we got aware of the standard. So we decided, okay, what can we do? At least we can, let's say, take this further. So we got in touch with the technical CACAO committee, became a member of WASIS, discussed our next goals. Those were to make it shareable via MISP in particular. And therefore we made the implementation and created the MISP object. The MISP object is now in the official MISP repository, so you can use it. We described our joint effort in a paper. And that is to conclude my presentation. So basically what to take away. We think that we need, let's say, more complex type of IOCs to face the new threats. This new IOC could be, for example, the machine learning classifiers. There is the second use case of collaborative machine learning, so to improve collaboratively our capabilities. And then the second bit is in the playbooks, where we hope that the playbooks can serve for automation of reactions of the steps, how we react to incidents. We prepared also the first prototype in case of the new IOCs. We are in touch with another European project called Concordia, and they develop a DDoS clearinghouse, and exactly they like the machine learning model to represent the fingerprint of a denial of service attack, because so far they fingerprint the denial of service attack only based on the IP addresses. So this gives far better representation of the attack. So that's where we plan to go further with machine learning, with the classifiers as IOCs. And regarding the CACAO, we stay at the Oasis, and we will, let's say, test our representation of the playbooks with multiple companies in the future to see whether there's something missing and whether it's viable. And yes, in the future, I expect that either open source communities or various business models will be introduced, and hopefully some of the concepts will make it to be, let's say, practically deployed in the end. And that's the conclusion of my presentation. Thank you for attention.
Okay, thank you, Martin. Thank you for your interesting presentation. So I would like to ask our audience if anyone has any questions. You can also type your question in the chat, and Martin can try to answer it. Okay, so I don't see any specific questions. So in that case, I suggest like we